Past experience of a large manufacturing firm with administering a test to recent college graduates who had applied for a job revealed that the mean test score was 500 and the standard deviation was 50. The distribution of the test scores was normal. What is the probability of having a score less than 470? So we have a normal distribution for these test scores, and we have the mean, and we have the standard deviation for this normal distribution. So the mean was 500 and the standard deviation was 50. We are looking to calculate the probability that the test score will be less than 470. To calculate this probability using a normal distribution table, we have to convert the value of our variable of the test score, which was 470, to the corresponding z value to use a standardized normal table. Z value, once more, will be the difference between the value of our observation minus the mean divided by standard deviation. In our situation, we have 470 minus 500 divided by 50. Because our value is less than the mean, we expect to have a negative z value for this test score. So this is negative decimal 60. On a standardized normal curve, we have the area under the curve, because it's for an entire probability distribution, equal to 1. We have a perfect symmetry. The middle value, which is also the median, because it's a perfect symmetry, corresponds to a z value equal to 0. On the right side of the diagram, we have positive value for z. On the left side, we have negative value. So our value is a negative value, so will be negative decimal 60. And we are looking to calculate what is the probability corresponding to z less than decimal 60. In our situation, it's the area under the curve below negative decimal 60. Based on this normal table, we can calculate just for positive value for z values, but we have a perfect symmetry. So the area that we are looking to calculate is similar with calculating for positive value decimal 6. All that we can read from the table, it's the area between z equal to 0 to z equal positive decimal 60. This area will be the same as the area between z equal to 0 and z negative decimal 60. Let's read this area from the table. So we are going down on decimal 6 and to the right to 60. So this area you can see is decimal 2257. So this area will be decimal 2257. The area that we are interested in is the red shaded area, because we have a perfect symmetry. Half of this area is decimal 5. So we have decimal 5 minus decimal 2257. So the area that we are interested in is decimal 2743. So this will be this area. So we have decimal 5 minus the area that we read from the table. So when we try to interpret this answer, we'll say that 27.43% of graduate students will have a score less than 470. So we need to calculate what is the probability of having a score more than 586. So we are looking to calculate probability when x is more than 586. Similar, we have to convert to the corresponding z value. So if we plug in our formula, we have 586 minus 500 divided by standard deviation that was 50. This time we have a positive value for z because our test score is larger than the mean. So if we compute the corresponding z value, is positive 172. We prepare again the bell-shaped curve of the standardized normal curve with z equal to 0, and now we have to the right, because it's a positive value, z equal 172. We are looking to calculate the probability of having a score more than 586. So it will be the area under the curve that it's more than 172. Again, from the table, we cannot read this area. We can read the area between z equals 0 and z equal 172. So this is the area that we can read from the table. So we are going down to 170 and to the right to 2. So this will be the corresponding value. So this area is decimal 4573. Because we are interested in the red shaded area, so this will be decimal 5 minus decimal 4573. Again, the total area under the curve is 1, half is decimal 5. So to calculate this area, we subtract from decimal 5 the area that we read from the table. So this is decimal 427. So for decimal 27% of the recent graduate students will have a score more than 586. What is probability of having a score between 450 and 578? So we are looking to calculate the probability when x is between 450 and 578. In this case, we have to calculate the corresponding z value to 450 and the corresponding value to 578. So z1 will be 450 minus 500 divided by 50. If we calculate this value, we have minus 1. Z value corresponding to 578. So that Z value, so let's consider Z2, is 578 minus 500 divided by 50. So this will be 156. So we are looking to calculate the area between these two z values, negative 1 and positive 156. We read the area under the curve between z equal to 0 and 1. We are going down to 1 and 0. So this will be the value. So it will be decimal 3, 413. The area between z equal to 0 and 156. So we are going down to 150 and to the right to 6. So this area is decimal 4406, because we are looking to calculate the entire area between -1 and 156. This area will be decimal 3413 plus decimal 4406. So we have a total area equal to decimal 7819. So 78 to decimal 90% of graduates will have scores between 450 and 578. Based on this experience, management is considering placing a person whose score is in the upper 5% of the distribution directly into a responsible position. What is the lowest score a college graduate must earn to qualify for that particular position? So right now we have the probability and we need to calculate what is the score that corresponds to this upper 5% probability. Before we had the x value, we calculated the corresponding z value and we read from the table the corresponding probability. Now we have the reverse situation. We have the probability, we calculate the corresponding z value in the normal standardized table, and we calculate the corresponding x value. We have to the upper 5% probability. We know that to read z corresponding to this probability, in the table we read the probability between z equal to 0 and this value. So we can identify this probability because half of our graph, due to the perfect symmetry, is decimal 5, and we have 5% in the upper side of this graph. The remainder is 45%. So we have a probability that is decimal 4, 5, and I'll add 20 because we have the probabilities in the table with 4 decimal places. Now we read the table inversely. So we are looking inside of the table, which is the closest value to decimal 4500. So if we are checking our table, we have these are the closest value. So the closest value are decimal 4495 and decimal 4505. Our probability is exactly in the middle. So we calculate what is that corresponding to decimal 4495. This is 1.6 and 4. Corresponding to decimal 4505 is 165. Because our is exactly in the middle, we can calculate the average between 164 and 165. So 164 plus 165 divided by 2. So the corresponding z value is 1.645. So z value corresponding to this probability, once more guys, I'll try to change the color. So it's 1.645. We have z value, we have the mean, and we have the standard deviation. We are looking to calculate the corresponding test score. So I'll plug in my formula. So I'll make a bit more room here to calculate this value. So we have z 1.645 equal x minus 500 divided by 50. So the 1.645 times 50 is x minus 500. When we calculate x, we move 500 in the other side. So our x will be 1.645 times 50 plus 500. So we have 582.25. So corresponding to the upper 5%, we have a test score, a minimum test score of 582.25. So the lowest score for this particular position will start from a test score equal to 582.25.